Portal frame construction is a method of building and designing structures, primarily using steel or steel-reinforced precast concrete, although they can also be constructed using laminated timber such as glulam. The connections between the columns and the rafters are designed to be moment-resistant, that is, they can carry bending forces. They were first developed in the 1960s, and have now become the most common form of enclosure for spans of 20 to 60 m. Because of these very strong and rigid joints, some of the bending moment in the rafters is transferred to the columns. This means that the size of the rafters can be reduced or the span can be increased for the same size rafters. This makes portal frames a very efficient construction technique to use for wide-span buildings. Portal frame construction is therefore typically seen in warehouses, barns and other places where large, open spaces are required at low cost and a pitched roof is acceptable. Generally, portal frames are used for single-story buildings, but they can be used for low-rise buildings with several floors where they can be economic if the floors do not span right across the building. A typical configuration might be where there is office space built against one wall of a warehouse. Portal frames can be clad with all sorts of material, but the most popular solution, for reasons of economy and speed, is some form of lightweight insulated metal cladding with cavity masonry work to the bottom 2 m of the wall to provide security and impact resistance. The lightweight cladding would be carried on sheeting rails spanning between the columns of the portal frames. Portal frames can be defined as two-dimensional rigid frames that have the basic characteristics of a rigid joint between column and beam. The main objective of this form of design is to reduce bending moment in the beam, which allows the frame to act as one structural unit. The transfer of stresses from the beam to the column results in rotational movement at the foundation, which can be overcome by the introduction of a pin-hinge joint. For warehouses and industrial buildings, sloping roof made of purlins and ash sheet roofing between portals is provided. For assembly halls, portals with a C-slab roof cast monolithically is used. Portal frames are designed for the following loads: roof load, wind load. While designing, care should be taken for proper joints, foundation, bracing. If the joints at B, C, and D are not rigid, they will open up, and the frame will be unstable when subjected to loads. This is the pack of cards effect. Vertical loading results in A and E pushed outwards. If the foundation cannot resist horizontal push, outward movement will occur and the frame will lose strength. Wind subjects the frame to uplift forces. Overturning forces on the sides and ends of the building. Drag forces on the roof and sides. These destabilizing forces are resisted essentially by the weight of the building, and in this regard, the foundations contribute significantly to this weight. The foundations are regarded as the building's anchors. References: